Okay, our last section in chapter 6 is called Relationship Between the Speed and Size of a Machine. And yes, the maximum allowable temperature rise establishes what we would call the nominal power of a machine, but its basic physical size, the machine's basic physical size, depends upon two things, and those are power and speed of the motor. So let's look at something here, and then we'll talk about what we're getting at. The main thing that I want you to get to with this whole idea is, you know, for a given machine with a certain power rating, the higher speed, the higher the power rating, and say the relative size of the machine. If that same power is needed out of the machine at a lower speed, then you have to increase the size of the machine to be able to get that out of it. All right, so let's walk through this idea. So Wilde says, consider this 100 kilowatt, 250 volt, 2000 RPM generator that we have here in figure 6.8. And suppose we have to build another generator that also has 100 kilowatts and voltage at the same, but we want it to run at half that speed, or 1,000 RPMs. To generate this same voltage out at half the speed, we would either have to double the number of conductors or double the flux from the poles. Consequently, we would have to increase the size of the armature or increase the size of the poles. In practice, both are done, not one or the other. And so the conclusion is, for a given power output, a low-speed machine is always bigger than a high-speed machine. And this is true for AC or DC machines, okay? So look here, 300 kilograms, 100 kilowatts at 2,000, 100 kilowatts at 1,000, and look, it needs to be a bigger machine because of that. Armature, conductor size, poles increased. Basically, the size of the machine depends uniquely upon its torque. So this machine, 100 kilowatts at 2,000 RPMs, has about the same physical size. This would have about the same physical size as a 10 kilowatt motor at 200 RPMs. Okay, so decrease by a factor of 10. And look at the relationship between the speed. Okay, so that's something I want you to take away from. Low-speed motors are much more costly than high-speed motors of equal power. The reason for that is the size increase, the copper increase, or the amount of flux or pole size has to increase. For low-speed drives, it's often cheaper to use the smaller high-speed motor with a gearbox than to use a large low-speed motor directly coupled to its load. Okay, so the advantage goes to the higher speed to get a certain output out that we're desire, and this goes through the multiple reasons why. Okay, so we'll call that the end of chapter 6. I think an interesting chapter, not a particularly difficult chapter. I got a few problems that I'm going to assign to you, and I'll post a quiz, and we'll call that a wrap and move on to the next thing.